This presentation is about the precipitation vertical profiles estimated by satellite-based passive microwave retrievals. The vertical profile information of precipitation is important for understanding precipitation systems, and it's also useful for improving surface precipitation estimates. The precipitation estimates from satellite-based passive algorithms are the major source of information for global precipitation monitoring. However, nearly all validation studies examine only the surface precipitation estimates. So the questions here are, how well do the passive microwave algorithms estimate the vertical profiles of precipitation? And is there a connection between the performance for surface precipitation estimates and vertical profile estimates? The target here is 1 year GMI observation, and the algorithms evaluated are GPROF by NASA and EPC algorithm developed by us. And we used the radar radiometer combined algorithm as a reference for surface precipitation rate and vertical profile condensed water content. Results. Here is the average profiles for mid to high latitudes. Combined algorithm, EPC, and GPROF. In general, the shapes are well captured by the passive algorithms, but the magnitudes are estimated with bias. EPC shows underestimation for convective precipitation. GPROF shows overestimation for stratiform precipitation, and also the underestimation for convective precipitation. So what about the global pattern of the biases? This is a column average condensed water content as a metric for profile magnitude. EPC shows the 20 to 50% underestimation in the mid to high latitudes, but it's unbiased in the low latitudes. GPROF shows the 20 to 50% and more overestimation in the mid to high latitudes, and also the 50 and more overestimation in the low latitudes. So the magnitude bias differs by the regions and the surface types. Next one is about the question 2. Is there a connection between the performances for surface precipitation estimates and the vertical profile estimates? This is a joint analysis between the surface precipitation error and profile magnitude error. There is a clear positive relationship between the two types of errors. And good estimates of the surface precipitation are accompanied by the good estimates of the profile magnitude. So there is a connection between the estimation performances of the surface precipitation and its associated profile. This is a joint analysis between the surface precipitation error and profile shape similarity. And again, the good estimates of the surface precipitation are accompanied by the good profile shape similarity. So physically reasonable connections between the surface precipitation and its associated profiles are achieved by the passive algorithms. Here's a summary. The passive algorithms can represent the average shapes of the precipitation profiles, but there are some biases for the profile magnitude. There are connections between estimation performances of the surface precipitation and its associated profile. This indicates that physically reasonable connections between the surface precipitation and its associated profiles are achieved to some extent by the two passive microwave algorithms. Thank you for your listening.